Cool. So we've got a lot of awesome functionality in our game now. So you can see the player jumping because they're so excited, and you see all these obstacles moving through the scene. Now, the one thing that you notice is that the player is standing incredibly. Oh, that's either because of one of two reasons. Either the player is moving so slow that they're not actually moving at all, or the player's moving so fast that our eyes can't even perceive how fast the player's moving, and so we can only see it as standing still. I'll leave that up to your own interpretation. So in order to actually make the player look like they're moving in the scene that's constantly moving back and forth, we're going to need to play with the player's animation. So what we're going to do is we're actually going to click on the player, and then in their inspector you can see that there's actually an animator component already applied to it, and it has a controller for a simple character. So what we can do is we can actually double click on that simple character box, and now you see that it actually opens up a brand new window in our scene for animators. Now, if you want to see all the different windows that you could actually add to Unity, you can actually see on the top left, there's the window button, and then you can actually add a bunch of other windows that you can use. One that you might have seen before, actually our console, is where the game over message is being sent. So you can add other windows if you want to. So now in our animator window, you can see that we have a strange view of this button that says entry, but not really anything else. You can actually move around in this view. There's a lot more going on. So we can press the Alt key and hold it, and then left click and drag, and we can move around our little animator window here, or we can use our mouse wheel and scroll in and out to zoom in and out. And if you click on your mouse wheel and hold, and then you drag it around, you can actually move around that way. So there's a lot of different things happening in our little animator window here. Now, first and foremost, the animator controller is the way that we actually control the states that the character is in at the current moment. So, in fact, when we're pressing play, our animator controller goes straight to our idle animation, which is why it looks like the player is not moving at all. So, the player's not moving. Surprise, they're not moving incredibly fast, they're just not moving at all. So our animator controller actually controls all the different states that our character can be in. So our character can be idle, and then from idle, these arrows actually mean that they then can go into one of these different states. So it can go from idle into a walking static state, which means that they're not actually walking in a direction, they're just walking in place. You can also run in place with run static. You can walk in a direction using walk, or you can run in a direction. And so if you started to move, for example, maybe it'll go to the walk animation, and then when you stop moving, it'll go back to your idle animation, so you stand still. Now, a really cool thing is you can actually see what these different animations are like. So if we zoom in a little bit, if we were to double click on idle, you can actually see that it pops up a little animation preview, and we can actually press play. And you can see that the model isn't actually really doing anything. You can see it's just kind of waving its arms back and forth. If we choose, for example, walk static, double click on that, we have another animation. And so you can see it actually looks like this character is walking, which is cool. If we double click on run and we press play, you can see that this one is actually moving through the scene compared to if we go to run static, this one runs in place. So very helpful to know the states of all these things. If we take a look at the arrows, you can actually see all the different conditions that need to happen to actually make the character move, which we'll go into in our little animator window here. Now, first and foremost, the animator controller is the way that we actually control the states that the character is in at the current moment. So, in fact, when we're pressing play, our animator controller goes straight to our idle animation, which is why it looks like the player is not moving at all. So, the player's not moving. Surprise, they're not moving incredibly fast, they're just not moving at all. So our animator controller actually controls all the different states that our character can be in. So our character can be idle, and then from idle, these arrows actually mean that they then can go into one of these different states. So it can go from idle into a walking static state, which means that they're not actually walking in a direction, they're just walking in place. You can also run in place with run static. You can walk in a direction using walk, or you can run in a direction. And so if you started to move, for example, maybe it'll go to the walk animation, and then when you stop moving, it'll go back to your idle animation, so you stand still. Now, a really cool thing is you can actually see what these different animations are like. So if we zoom in a little bit, if we were to double click on idle, you can actually see that it pops up a little animation preview, and we can actually press play. And you can see that the model isn't actually really doing anything. You can see it's just kind of waving its arms back and forth. If we choose, for example, walk static, double click on that, we have another animation. And so you can see it actually looks like this character is walking, which is cool. If we double click on run and we press play, you can see that this one is actually moving through the scene compared to if we If we go to run static, this one runs in place. So very helpful to know the states of all these things. If we take a look at the arrows, you can actually see all the different conditions that need to happen to actually make the character move, which we'll go into a little bit on how we can edit those and see those. So you can see we have these conditions for an actual speed. So say the player is not moving, their speed is 0. And then they start moving and it reaches a point where it's 0.25. Then it will actually go into this transition, and you can see this transition happen. So they're stopped, and then they start moving. And then if we take a look at the arrows, you can actually see all the different conditions that need to happen to actually make the character move, which we'll go into a little bit on how we can edit those and see those. So you can see we have these conditions for an actual speed. So say the player is not moving, their speed is 0. And then they start moving, and it reaches a point where it's 0.25. Then it will actually go into this transition, and you can see this transition happen. So they're stopped, and then they start moving, and then it goes into walk static, and the player is just moving. So now what you're going to do is you're going to left click on the player in the hierarchy, and then under the inspector in the animator component where you see controller, you're going to double click on So we've gotten to move around our animator window just a little bit, and we've gotten to go and look into some of the animations themselves and preview them. And we've seen some of the movements between all the transitions. So now what we're going to do is we're actually going to play around with the values in these transitions. So knowing that our transition for our speed needs to be greater than 0.25 to be able to start this walk static animation, we can actually go over on the left side of the animator window to parameters. And if we click this tab, we have a parameter section that opens, and here you can actually see the parameter of the speed that we can set. So in fact, if we make this, for example, 0.3, because 0.3 is greater than 0.25, and now when we press play in our game, we can actually see when the player enters the game, then it should go into the idle state, and then it'll go down to the walk static state. So we're in idle, and then it starts walking. Now, it looks a little weird because the background is moving incredibly fast compared to the actual player. So let's see what kind of speed that we need to have. We need greater than 0.5. So we'll make this like, we'll just make this 1. So it's definitely more than 0.5. So we press play. There you go. And then you can see it goes from the walking to the running animation. Now that does look kind of weird because the scene is just moving. So we can actually set a default animation state. So if we go to our run static here and we right click on it, we can actually set as layer default state. So if we select that, you can see our entry state goes directly to our run static instead of to idle, because from idle we had to go to walk static all the way to run static. Static, and that just took way too long. So now when we press play, you can see that the player starts running. The animation's still a little too slow, but we can fix that really easily. So you can see on our different states, there's actually some information in the inspector. So you can see actually the speed of which the animation runs. So since the player looked like they're running a little slow comparatively, we'll set this to something like 1.5. And now we'll play this animation. And there you go. Now it looks like the player's really running, and then they jump in. They're still running, but that's fine. We can fix that at some point. Now they're just moving so fast that they just end up back in the same place on Earth. And then one more thing that you can see is you can actually see different animation layers, which we'll go into, but it's just kind of interesting to see how they all work. So with the idle, you can see all these different idle states that it can go into. With jumping, you can go from idle to a standing jump or walk and then walking jump. There's different ways of dying or crouching. So there's all these different kinds of animation states that we can control based on certain conditions. So what you're going to do is you're going to start using some animations of your own. So make sure that you click on the play. Player in the hierarchy in their cool. So we've got it so that our player looks really good while they're running through the scene. But we do have another weird thing where it's pretty awkward that they're still running while they're jumping, unless you're in like an action movie. That's not really something that people usually do. So we're going to do some things to the jumping animation to really make it look real. In fact, we're actually going to use our player controller script to be able to do that. So if we go to our assets, and we can just close off the source files, collapse them because I opened it up when we opened the animation controller. And now if we open our player controller script, now in our player controller script, we're actually going to get a reference this time to our animators. So similar to how we got a reference to our rigid body, we're going to get a reference to our animator. So we'll also make this private because we don't need to find this outside of our class. It'll be of type animator, not animation, and we'll just call this player anim for now, for player animation. Now, just like our rigid body, we actually need to get the actual component on our object. So player anim is set to our get component. And what component are we getting? Our animator. And then make sure to call the method and close your statement. Now, if in our update function is actually where we want this animation to happen, but what animation exactly are we trying to make happen? Well, let's see. In Unity, if we go to our animator, and we find our player animator, now, if we take a look at our layers again, you can see that we have all of our different layers, and we want our player to jump, so we'll go to our jumping layer, and we're going to center all of our animation states. Now, we have one that goes from run to running jump. Now, how do we get there? Interesting. So, you can see, to get from run, under our conditions, there's something called a jump trig. So let's see if in our parameters, so we do have something called a jump trig that we would be able to use. Now, if we follow the naming of all of these different variables, so you can see we have speed underscore f, and it has all these decimals next to all of them, so that must be a float. And under animation int, so that's an integer, they're whole numbers. Under our static b, crouch b, so since they're checkboxes, they're probably booleans. So I think our jump trig is probably actually a trigger that you could think very similarly like the triggers on our colliders. So, in our player controller script, so we have this place where we make this jump actually happen. So let's see, so if we use our player animator, let's take a look at some of the methods. Wow, that's super convenient. Dot set trigger, set the value of the given trigger parameter. And it's got an overload. Well, let's see, that seems like something that we want to use. So we'll use set trigger. That way we can use our jump trig. Let's see, maybe, what's the other option? Oh, I can just use the name. So, if we set this to be, I believe it was spelled like so. Now, this set trigger method should activate our jump trigger. When we press the spacebar since it's inside our if statement. Well, let's give it a try. Let's see what happens. So if we play our game, and we jump. Oh my gosh, that was a little weird, but we have the jumping animation. Let's cool. Kind of looks like it's like Superman or something, superhero. All right, so to get started activating these animations, what we're going to do is in our player controller class, make sure that you add your own animator variable, and then in the start method, make sure that you assign your animator variable to the animator component. And then in our update method, great, now our player character animations are in a really good place. We have our running animations, and then when we jump, you can see we jump for joy, but we have this weird little issue where when we jump, the animation stops short, and then we start running in the air, which doesn't really look right. So we're actually going to go into our running jump animation. And similarly to how we set the speed to be a little bit faster for the run to just make it look like the player's running faster, we're going to set our animation speed just a bit slower. We'll do 0.7, just so that the animation now runs just a bit longer instead of faster. So when we press play, now when we jump, the animation definitely works a lot better. It lasts a bit longer. I think one thing that we're going to do just to make it look a little bit more realistic is we're actually going to go into our player object, and we're going to play around with some of the variables, so specifically our mass, our jump force, and our gravity modifier to just make it look a lot more realistic and better for what we want to be. So our mass on our rigid body is a little low. People don't normally weigh just 1 kilogram, so we're going to change our mass. Usually on average a person weighs about 60 kilograms or so, so we'll see what that does when we press play. And we have the jumping animation, but we don't really go anywhere. So let's play around with the jump force a little bit. Maybe let's set it to a little bit over, like 10 times the actual mass. So we'll do like a 700, we'll see how that looks. Ooh, I got a little bit high. So maybe... Let's see. If we go to our gravity modifier, let's make it a little bit more. Let's make it like a 1.5. And now when we jump, not bad. Pretty close. So we can probably fiddle with these values a bit more, but it looks pretty good. We get pretty close to the ground before we start running. So now what you're going to do is, in your player animator window, if you go to the jumping layer, and then we click on the running jump, so we'll set the animation speed to be a little bit slower, so I set mine to 0.7. And then on our player object, we're going to Cool, so we've hit the ground running now. We have our running animation set up, we have a jumping animation, so we can fly through the air, so excited. Now we just need to add one more thing, which is whenever we collide with one of these barriers, we're not just going to keep running into one of the barriers. So what we can do is we can use one of our other layers for character deaths. Now in our deaths layer, you can see all the different kinds of states that they can go through, so we can go from alive to a death 1, so let's see if we double click that, and we'll see, we'll play that, see how that looks. Falls over, and then death 1 is just the character falling over. Death 2, what does this one look like? Falls over in front, so falling over front doesn't really make any sense in this case, so we'll probably just go with death 1. Now, let's see how we can actually make this death animation play when it happens. So, let's see the transitions here. So, let's see, the conditions are, so the death bool should be set to true, and there's a death type integer that's equal to 1. So, as a good way to kind of manage the state, we can actually see the second transition, and you can see death type becomes equal to 2 in that case. So, since we want the first death animation, that's the one that we'll go with. So, if we go into our scripts again, all the way down at the bottom here, go to our player controller script. So now in our player controller script, we're going to go to the place where we end the game, where we have that game over bit of code. So down in our on collision enter, you can see if we collide with an obstacle, then the game is over. So this seems like a pretty good place where we can actually make this death animation occur. So let's see what kind of methods we have for our player animator. So let's see. So we had set trigger to set a trigger. Now that death B was a bool, so can we set bool? Oh, cool, perfect. So we'll set bool. And we wanted the death bool to be true, so let's see. We can use an int ID, or we can use a string name. So I believe the name was capital D F underscore B for the bool. And then the value that we want to set it to, so in this case, we set it to true. Cool, so now we set death to true, but we need to actually make sure that we select the proper death type. So let's see if we can actually set that to. So player, anim, and then let's see, it's dot, so it's an integer, so cool, so there's a set integer option too, so we'll select that one. And I believe, I can probably use a string again, just double check, string name, so then I believe it was a capital D, F, capital T, type, and then an underscore int, and then I believe the one that we wanted was the first one, so 1. So now if we save, so hopefully if we typed everything properly and we set the proper values, it should, when we go into our game. Cool, so when we play, let's see what happens when we run into the obstacle. Wait for one of them to spawn. Oh, there they go, and falls over, and then it goes into the dead state in our animation, so perfect. So, now what you're going to do to add in this animation Cool, so we've set it up so that when our player runs into an obstacle, it'll start the death animation. But there is one small problem that we actually need to fix, which is when we press the spacebar, we're actually still able to jump, and that's definitely not something that should be possible. So we're going to need to change our code just a little bit, so that way we don't just magically jump even though technically the game is over and the player has died. Now, in order to prevent our player from jumping over and over again when the game is over and they've lost, we'll actually need to change the condition of our if statement. So, perfectly fine that they press spacebar and they can jump, and to make sure that they are on the ground when they jump, but we do need to make sure that the game is not over, otherwise they'll still be able to jump when the game is over. So, we're going to add an AND symbol here, so 2 ampersands for AND, and then we're going to use if game over equals false. So if the game is not over, then this thing will run. In fact, there's actually an easier way that we can do this. So we can actually use what's called an exclamation point and set this to true. So in this case, the exclamation point actually negates the statement after it. So if game over is not equal to true, so the same thing as saying game over equals false, then it will do this thing. In fact, there's actually even a shorter way that we can write if the game is not over. For Boolean values, we can actually just put that exclamation point in front of game over. So in this case, this says, if the game is not over because of this exclamation point, then do these lines of code. Now if I save, we can see if this code really worked when we press play. So if we press space, we can still jump, and then if we hit one of the barriers, the player runs into it, and then we press the spacebar and we can't jump anymore. So, a really easy way that we can prevent the player from jumping after the game is over. So, what you're going to do is in your update method, in the player controller, you're going to add in your if statement Alright, so we've made it to the end of this lesson, and to wrap everything up really Alright, so we have a really good looking game now, with all of the cool mechanics and animations set up properly, and now we're just going to add the finishing touches when we collide with that obstacle to create a really cool smoke effect. So, to do that, we're actually going to learn how to use particle effects. Now, if you go into your assets, under the course library, there's actually a particles folder, and if you expand the particles folder, you can see there's dirt splatter and smoke explosion. So we're We're going to take this explosion smoke and drag it into our hierarchy. And then you can see it creates this really cool puff when we place it. And you can see there's... So we're going to take this explosion smoke and drag it into our hierarchy. And then you can see it creates this really cool puff when we place it. And you can see there's actually a little section down in the bottom right of our scene. We'll make that a little bigger. And in this menu, you can actually play, restart, or stop the animation of our particle effect. So if we play, and we can restart as much as we want, and we can stop it, and we can play. So it's just a kind of cool way to see the effects and how they work. Now, another cool thing about our particle system is that there's a whole bunch of options that you can actually change on the particle system to be able to make it do different things. So you can actually go and change how fast the actual particles move over their lifetime. So if we set the speed to be 10 times as fast, it should move even faster than before. Yeah, so it's like a big... That's actually kind of cool. I'm going to leave that. So we'll stop that. So it's pretty cool. We can set different options too that we want. So we could change the colors if we wanted to. We could change how they actually expand. All these other different options. Actually, no, I'm going to set the speed back to B2. So there's all these different ways that you can play around with particle effects. Honestly, you could do 100 different things with them. I'm not going to go too crazy just because the base effect is really good for now, so we're just going to use it. One thing that you want to be really careful of, though, with your particle effects is if you open up the particle system menu, you can actually see there's a play on awake, and if we set that to true, so that would immediately create a huge puff of smoke when the game starts. That's not exactly what we want to happen. That's not the kind of effect that we're trying to create, unless this character were a magician. That would make a lot more sense. So we'll uncheck the play on awake. So now one thing that we're going to do is actually put this explosion smoke underneath our player as a nested or a child object. So that means that it's an object that is attached to another object. So it belongs as part of that object. So you can actually see player, you can see like the character, and you can see the actual legs that control it. If we drag in our explosion smoke on player, you can see now that player has a smoke explosion effect attached to it. And now what we can actually do is when we play, we can actually like move our particle effect around. So if we restart, see it kind of starts kind of high. So we can actually go and maybe let's just set the Y down to 0. So it's at the bottom of the player's feet. And then we restart, and there you go, now it's closer to the ground. Maybe we'll make it a little bit higher. Something like, whoa, no, too high, 0.5, I think is good. And then play. Cool, so that's a pretty good position. So you watch at the bottom, it's like a puff of smoke. And it creates a really cool effect. So now what you're going to do is you're going to go... Cool, so we have this cool smoke explosion here that we can play. But one of the things that we need to do is actually make it play when the player runs into one of our obstacles. So if I time it right... So something like that, pretty close. The computer can probably do it better than I can, so we'll just have the computer do it. So we can actually do that by going into our player controller script, and then in our player controller script, very similar to how we got our components for our rigid body and our animator, we'll do something similar. In this case, because our particle system is actually outside of our player components, we'll make this a public particle system, and we'll call this the explosion particle. So now this will create one of those variables in our component that we need to drag something onto, so we'll do that later. Now in our player controller if statement, whenever a player runs into an obstacle, this is where we're actually going to make our explosion particle happen. So when the player dies, we can add another line, and we have the explosion particle now, and we can actually just play the particle, and so the entire animation effect will just play as soon as it hits this line of code. So we run into an obstacle, game over happens, player dies, and it'll play the explosion effect that we have. And then in Unity, just make sure when you go to your player object, you take your explosion smoke and drag it down to the player controller script and drop it into the explosion particle. So now, when we press play, when the player runs into an obstacle, we should see a big puff of smoke. Perfect, that's exactly what we were looking for. So, now what you're going to do... Alright, so our particles are getting pretty good right now. When we run into one of these obstacles, we get that big puff of smoke. So, we're going to add a little bit more to our character. So we have this cool dirt splatter effect. So we're actually just going to drag this onto our player. And now we have that dirt particle effect. Now it does look a little weird. You can actually see it's like spinning out in front, and in this case to the side. That's not really how running works. So we're going to make it so that we can face this dirt particle to the back. So what we'll actually do is we're just going to use our rotate tool in the top left. We're just going to rotate this, I think, on our Z-axis. There we go. Looks pretty good now. Probably like directly to the back. Cool, looks good. If you want to, you can just, I'm just going to clean up this value in our rotation, so I'll set to -90. That way it's definitely facing backwards. And then if you want, you can even mess with the Y rotation and make it face a bit more upwards or downwards if you want to. Up to you. Really whatever you want to do. I think that angle's pretty fine for me. And then we're going to go into our player controller script once again. And then in our player controller script, just like we did with our explosion particle, we're going to make a public particle system so that way we can attach it. And then this will just be, we'll call it dirt particle, very simple. And then what we actually want to happen is when we're jumping, we actually don't want to play our dirt particle anymore, so it's always playing already. So we'll actually set our dirt particle, let's see, dirt particle, so we can play. So I wonder if we go to the options, is there, so we can stop. So that seems pretty helpful. So let's stop our particle from playing. And then when the player lands back on the ground, that's when we want it to start again. So we'll play when we touch the ground. And then it would look pretty weird if dirt was still coming out from behind the player if the game was over and they died, so we're just going to stop that particle from playing when they run into an obstacle. Now when we save, so you can see when we go back into Unity, in fact, the play on awake is actually set to on for our dirt splatter, which is fine, so that you can see it when the game actually starts. And then when we press play, You can see we're running, we're making dirt, and then we jump, and we're still making dirt somehow. Maybe it's stuck to the player's shoes. That probably doesn't make any sense. Well, the explosion still works, so that's cool. Now you can see that there's just magical dirt being thrown out. Into the sky. Maybe there's like an animal underneath the player that's actually creating the dirt. Who knows? I think we might have skipped a step. You can see. Oh, so in the bottom we have an error. So dirt particle has not been assigned. So I believe in player. You're going to take one of the dirt splatter particles, drag and drop it onto the player, and then you can just set its position. Alright, cool. So we've got some really good effects happening right now. So if we press play, you can see that we have dirt that comes out when the player runs, and then when they jump, the dirt stops, they land, the dirt starts again, and then when they run into one of the barriers, a huge puff of smoke comes out. Now, to really finish out this game and give it that nice last bit of polish that it needs, we're actually going to add sounds and some music. So, what we're going to do is, if you go to your main camera, now on your main camera, there's a very interesting component on the camera called an audio listener. So much like you need ears to hear in the real world, or on a camera you need a microphone, in Unity you need to add an audio listener to be able to hear sounds in the environment. Now, another thing that we can add to our main camera, if we go to add component, if we actually type in audio, you see there's all these options, and in fact we can actually add in an audio source. So our audio source is actually where we can get audio like clips of music or sound effects to actually play. So we're going to go into our library again of our course. In our course library, you should actually see a sound folder. So if we expand that, now we have two options for music or sound effects. In this case, we're going to add some music, and there's three different options that we can play from. You can see when you click on one of the effects, if we press play in our little preview, that beat's really cool. Let's see if we do the second one. That was a little darker themed. We're not like in a nighttime forest, but that would be really cool. Or our last one. This one definitely screams happy forest. So we're actually going to use this sound effect, and we're going to go to our main camera. So I believe it was that third clip of music, so we'll actually drag this to our audio clip. Now, when we press play, we should just hear some music playing in the background. Not bad, sounds really good. Now, one thing we want to make sure is it seemed like a pretty short clip itself. It's like 48 seconds, so if the player makes it that far, then the music will just end, so we definitely don't want that to happen. So if we go to the main camera, we can actually just loop. And then it was a little bit loud, so we'll just turn it down maybe to do like 0.6 is probably fine. Fine. So 60%. I definitely didn't want to check that box. So now, when we play our game, again, we'll hear the music one more time, it should be a bit quieter. Not bad, so just set it down a little bit so that way when we add sound effects, we'll be able to hear the sound effects over the music, otherwise the music might be too loud. Cool, so with that, what you're going to do is you're going to go to your Cool, so we've got some background music playing in our game for our nice happy forest and our nice happy character jumping through the scene. So, one of the last things that we're going to do is we're going to add in some sound effects for the player. Now, sound effects are a bit different than using music audio, because we actually need to trigger those sound effects in our code. So actually what we're going to do is first we're going to go into our player controller script, and now in our player controller script, we're going to create two new variables. So the first one will be a public, and in this case, since we're actually using audio clips, we can actually just use the audio clip. So now we have an audio clip class, and we'll call this the jump sound. And then we need a second audio clip for our crash sound. So now that we have these public variables, now if we go back into Unity, you can see when we click on the player, so there's the jump sound, which has no audio clip, and the crash sound, which also has no audio clip. So we're actually going to go into the sound effects. So there's a bunch of different options for jump. Jumping and crashing. So we just make sure that we go back to the player and we'll just drag one of them. So I'll just do crash 2 for our crash sound, and then jump 3 for our jump sound. So now what you're going to do is in your player controller class, you're going to create two new variables yourself for the audio clips, one audio clip variable for the jump and one for the crash, and make sure that they're public so that way we can assign it when we get into Unity. And then in Unity, you're going to click the player, and then just make sure that you go into your course library, sound, SFX for sound effects, drag. Cool, so we've added our sounds for jumping and crashing, which is great. Now we're going to go back into our player controller script, and we're just going to create another private variable for our component. So this one will be, in this case, since we want audio, right? We want to be able to emit the audio from our player, so the player needs an audio source. So we take the audio source of our player, and we'll just call this player audio. So this is the audio that plays from the player. In our start method, we're very familiar now, so we'll use our player audio variable, and we're going to set it to our audio source. Component. So get component audio source. So now since we have our jump and our crash sound, what we need to do is actually play those audio clips. So down in our code, when the player jumps, we're actually going to use our new player audio variable, and we're going to use a new method. And so there's specifically one called play. There's a play on awake, so when anything starts, it'll play. And then there's a play one shot. So basically that'll just play it once and then it'll be done. So we play one shot, and then we want our audio clip, so this is our jump. So our jump sound, and then it looks like there's another variable that we can add, so we can actually change the volume when we play our jump sound. So we'll just set it to be, we'll just leave it to the full volume for now. And then we're going to do the same thing, but when the game is over. So we're going to use our player audio, and we're going to play one shot, because we actually need to use audio clips in this. And then in this case, we're going to use our crash sound, and we're going to set it to full volume once again. Cool, now we save. So when we go back into Unity, now when we play our game, we should hear some effects when we jump and when we crash. Now we jump, and I didn't hear anything. What if we crash? What's gonna happen? It didn't seem like anything happened. Let's see. Let's look at our errors. There's no audio source. Oh, I made a mistake. So in player, we actually need to add the audio source because we didn't actually use one. So let's go add a component. We're gonna look for an audio source. There you go. So now that we have the audio source that we're using and we have the clips that the audio source will be playing, now when we press play, that error should go away. And we jump. There you go. And then I can't stop jumping right now. It's just too exciting. And then when I crash, finally, nice. Awesome. So now we have an amazing game full of sound effects and audio. So what you're going to do is you're going to make sure that you add an audio source to your player. Don't make that mistake like I. Alright, so we've made it to the end of the lesson. Now, as a nice little wrap-up, we did a lot of different things in this lesson. We added all of these really cool particle effects, so that whenever the player runs or whenever they crash into things, we have these cool effects happening. We added in some audio, and we added in some music, so whenever we're running, when we jump, you can hear that cool jump effect. When we crash, there's that cool little explosion sound. We have this background music happening. In our particle systems, we learned a lot. Welcome to Challenge 3. So, let's review what we did for our Unit 3 project. So we have our game here, and we have the cool, awesome sound effects and background music to make our player jump. You can see that background is scrolling and repeats all the time. We have all these different objects spawning. Cool. And then when we hit our object, we have a huge puff of smoke. Everything stops moving. So we have a good little game on our hands here. So let's see what this challenge is supposed to be like. So let's see. I'll press play. So we have some fun music again. That's exciting. So we have a balloon, and when I press spacebar instead of jumping this time, it's floating, floats up. And then we have these dollar signs, these money signs, and then we have these bombs. I guess I have to avoid these bombs. Oh, cool. If I hit the bottom of the ground, actually make a bouncy noise. It's fun. And then you have these cool effects that pop up when we grab the money. Let's see what happens when we hit a bomb. There you go. The balloon falls, the particle effects happen. Okay, interesting. And then the background also stops now that the game's over. That seems like a fun little game. Seems super upbeat, enjoyable. Alright, so let's see what's happening with our starter project. So, cool, audio playing. Okay, that was weird. I can't even control my player. Wow, this background is really disorienting. Okay, so the background is still moving, even though the game is technically over. Let's see what else is happening. Okay, the particles are kind of off there. There's not even any objects spawning. Okay, so there's a lot of stuff broken here. This is okay. Well, let's figure out what we're gonna do here. So, for challenge 3, we have a lot of different problems. First up, our player can't control the balloon at all. We want the balloon to float when we press the spacebar. Our second problem, the background only moves when the game is over. The background should move at start and then stop when the game is over. No new objects are being spawned, so we're just stuck with that $sign and that bomb that are there at the beginning. When we pick up that money symbol, the fireworks display in the center of our scene, which is not right. And then last but not least, our last problem is the background doesn't repeat properly at all, so we need to make it so that background repeats seamlessly. In terms of bonus challenges for this challenge project, one of our challenges is that the balloon will be able to float way too high, and so we actually want to prevent the player from floating their balloon all the way into the sky. And in fact, our balloon can also drop below the ground. That's definitely not how ground works, so we'll need to make it so that the balloon bounces off that ground, so we can keep the player within this range. So if we take a look at our game, in our scene, you can see if I get our balloon all the way up to the top, you see that it doesn't go all the way up, it gets blocked. And then, in fact, if I let go, our balloon does a cool little bouncy effect, so it makes a fun little noise too. Now, as you're going through each of these challenges and fixing each of the problems, if you ever get stuck or you need any help, remember that you have those hints that you can take a look at in case you need to remember how to do something or you need a little bit of help along the way. The bonus challenges are there just to push yourself a little bit further if you want to be a bit ambitious and make your project a little bit cleaner. And then if you get stuck at all, make sure you check out the instructions in your starter project. And then there's that handy little video that you can play to see what the gameplay's like. And with that, I'll let you get started on your Challenge 3 project, and good luck. So we know all of our different enemies, and we have our power-up, and we have our player, but we'll need to be able to control this player, so we'll need a script to control that behavior. So on our assets folder in our project window, we're going to right-click, create a new folder, and it'll be called scripts. Now in our scripts folder is where we'll add our player controller script. So we'll create a new C# script, call it player controller. Now we need to make sure we apply this script onto our player. player object. So I'm just going to left-click, drag that script onto our player, adds it into the player's components. Now that we've added our script, one other thing that we're going to do, in this case, I want my player to use physics, so I'm actually going to left-click on add component and add player, but we'll need... So we know all of our different enemies, and we have our power-up, and we have our player, but we'll need to be able to control this player, so we'll need a script to control that behavior. So on our assets folder in our project window, we're going to right-click, create a new folder, and it'll be called scripts. Now in our scripts folder is where we'll add our player controller script, so we'll create a new C# script, call it player controller. Now we need to make sure we apply this script onto our player object, so I'm just going to left-click, drag that script onto our player, adds it into the player's components. Now that we've added our script, one other thing that we're going to do, in this case, I want my player to use physics, so I'm actually going to left-click on add component, and add a rigid body, and I'll make sure it's using gravity, that way it always falls to the ground. And so this will be helpful because I know in my game that I'll be colliding with a bunch of other objects and I want to apply those forces onto my player, so that's useful for what I'm trying to do. But if your game isn't using physics, don't use rigid body, you don't need to, if you're not trying to do some physical collisions or anything like that. Now we'll open up our player controller script. Now before we go into writing any of the code to control our player, one of the things that we should consider is how we actually want our player to move. So in our first prototype, we made it so our player had full control over their movement. So they could move forwards, they could move backwards, they could move left, they could move right, they could drive down the road. In challenge 1, we had a plane that was already moving, but you could control that movement using the arrow keys. In our second prototype, we made it so we could move the player side to side, they were trapped inside of this invisible box, and they could also throw projectiles from the player. In our second challenge, our player didn't actually move at all, but we could use those projectiles as a way to drive our game. In our third prototype, we had the background moving, like an endlessly scrolling game, and the player just jumped over these different obstacles. In our third challenge, we took the jumping aspect a little bit further, and so while the game was moving, our player actually had to manage their height by using the spacebar to float up or down. In this case, for my project, what will happen is I imagine that I have all of these different cubes and this sphere, and they'll actually be moving up and down the scene. And so actually, I want full control over the direction that my player will be going, so they can move up, down, left, or right. And so I'm going to be using controls very similar to our first prototype. So what you're going to do is, in your project window, you're going to right-click on the assets folder, create a new folder, and it'll be called scripts. So that's where we'll store all of our scripts we make. And then in our scripts folder, we're going to right-click, create a new C# script that will be our player controller, and then we'll drag and So now that we know how we want our player to move, we need to actually make our player move. Our design document here is a great reference to have to understand what we need to do to move. So in my case, I have the arrow keys that I'm going to use, so I'm going to need some input. I'm not using spacebar or anything, so I don't need to do key codes or key presses. So all I'm doing is creating basic movement. So what I'm going to do first is I know that I'm going to use a speed to be able to maintain a consistent speed for my player. I'll make this a private variable because I'm just going to edit it later. I'm going to make it a float because I'm going to need those decimals, and then I'm just going to call it speed, and I will actually initialize this in my script now. So I'm just going to make it 10 for now. In case I need to change it later, I can just change that number 10, so not a big problem. Now because I'm actually using my rigid body to control my player's movement, I need to get a reference to that. So I'm going to get a private variable for my rigid body, and we'll call it player RB for the player's rigid body. Now remember, if you're not using rigid bodies on your own specific player, you don't need to worry about this step at all, nor do you need to worry about getting the component or anything like that. So in my case, I'm going to get the player rigid body, and I'm going to use that get component so that I can get the rigid body component that's already on my player. Now that I have my rigid body, since I'm using player input to control all 4 directions, I'm just going to use the horizontal and vertical axes for my input manager. So I'll make a float variable because I want that precision with the decimals. So it'll be a float, we'll call it the horizontal input, and we're going to get our input manager. We're going to get the axis we need, and since this is the horizontal input, we'll make it the horizontal axis. Now I do the same thing to get the vertical input, but I just change the word horizontal to vertical. So now we're getting both of our inputs, and now I need to actually move my rigid body. So instead of using a translate method to change the transform property, I'm actually going to add a force. And so I need to get that player rigid body, and I need to add force. Now in this case, in order to move forwards or backwards, I can still use a vector3.forward. Since I have that speed variable, I'll just make sure that it's multiplied by our speed in that direction. And then to control when the player is moving forwards or backwards, you use the vertical input. So when vertical input is not being used, if the player isn't pressing the up or down arrow key, then there will be no force applied. I can do the same thing with my horizontal input, so I need to add another force. In this case, I want to be able to move left or right, so I'll just use vector3.right. Multiply that by the speed as well, and then use my horizontal input. So you can see that I did something very similar whether I was controlling my player using forces or translating, so very helpful. Specifically since I'm doing everything using rigid bodies and collisions with my game, I'm just going to stick to adding forces because it'll be a lot easier to keep track of. Now, to see that this actually worked, let's test our game really quick. And then our player falls to the ground because we have gravity, and there you go. Now you can see my player rolling all around the scene. And then I can even bump into all these different things. I've applied rigid body. Dot right. Multiply that. up by the speed as well, and then use my horizontal input. Those, yeah, so they're just stoic objects. Now, in case you get lost or you forget how you actually implemented your movement, again, feel free to reference any of your older projects to see how you made the player move. So what you're going to do is, in your player controller script, you're going to add movement, so you're probably going to need a... So we've added in our player movement. So you can see our ball rolls all around, and then actually drove it straight off of the plane. So that's unfortunate, but that's okay. So we'll need to limit a lot of this for our gameplay. So one of the first things that I noticed was when I ran into specifically our capsule, it collided with it, and in fact, our capsule is actually going to be a trigger. So I'm going to just make sure I check that for now. So that way when I do collide with it, then I can do something with it, because I'll know I'll need that later. If you're not using power-ups or anything like that, don't worry about it. Just make sure to check all of your different collisions that you have. If you have like ground or something like that, just make sure that you have a collider on it, so that way it interacts in the way that you want it to. In my case, what I want to happen is, actually, at some point, I think I'm probably going to replace this ball with an animal or something like that, so I do need to do one thing. So in my player object, in the inspector, down in the rigid body, I have this little constraints drop down. So I want to be able to move it left or right. I might add in jumping later, or I might want to add that cool effect if the player gets hit, it jumps or something like that. But I don't want my player to rotate in weird ways. It's probably going to be an animal or something, so it would look kind of strange if it tilted to the left or to the right or something like that, or forwards or backwards. So I'm going to freeze the rotation. So that way I can still move. But now if I add in a deer or something like that, I don't need to worry about it as much. One of the big things that you noticed was that I actually flew off the edges of my world here. So the way that I imagine this game happening, and it'll help if I expand my game window so you can kind of see the perspective. So what I want to happen is all these different animals and stuff, they'll be coming up and down our game, but I don't want to fall off the edges of this world. I definitely don't want to go past the edges themselves. So what I want to do is I'm going to make this kind of, I imagine I'm going to be creating a valley of some sort. So I'm going to actually create some cubes that'll be in place of the walls of my valley. Just make sure I reset that position so it's not just flying in the sky. Now I'll move this one over to the left. Now you can kind of see it there. And I'm actually going to make it a bit taller. So it's kind of like a valley wall or something like that, and it's going through the ground, so let me bring that up a bit, like there. And I do need to make it longer too. One little pillar isn't going to be a lot, so I'm actually going to expand it on the Z. So there, now you can see I have this kind of wall. Let me just focus on that, make sure it's lined up with the ground really quick. We'll probably bring it up a little bit more like that. And then maybe about there, or so. A little tight, just about that. And then I'm going to duplicate this. So my other cube, I'll drag to the other side. Let's get that little piece of wall in there. Cool. Now I do want to rename these to be walls, so I'm just going to select the first key variable for that as well. So that way the player doesn't just keep jumping, you just restrain it to one jump or two jumps or something like that, if that's a mechanic you have. And then one thing, my walls are a bit hard to see, so I'm just going to create like a new material. I'm going to make it like purplish. That way I know it's like a wall, so I'll call it purple. Go about here. I'll make it like a dark purple. And if I left click and drag it onto my walls, there you go, cool. So I have purple walls, so I can see those. I'm going to kind of round out some of these values a little bit, so I'm going to make this 17. Oops. Negative 7. 17. And positive 17. There you go. Now, in my player controller script, I do need to constrain that movement on the Z-axis so that I can't move the player past the top or the bottom of their view. So I'm actually going to make another private variable for that. Make this a float, in case we need to get more specific at some point. We'll call this our Z-bound, so this will be our Z-boundary. And I believe that value was -6 and 6, so we'll just make this 6. Now, I'm constraining our player to -6 and 6. I don't entirely remember how to do that exactly, so I pulled up a quick reference of how I actually did that for our second prototype. So the code went somewhere along the lines of, so if the player's transform position, but specifically there's Z in this case because they're going up or down, so if it ever becomes less than the negative Z-bound, then we actually just reset that position to be a new vector position that we need. So in this case will just be, we keep the X, and we keep the Y, but then we keep it inside our negative Z-bound. Otherwise, if our position on the Z becomes greater than that 6, then we actually just do this line of code. So we're just going to copy this, paste this, and then just remove that negative. So now Now when I save, then I play my game. Let's see, now when we move up, we should just get blocked by an invisible wall. player can now move freely around the scene, as free as we want them to at least. So I have these walls that I've created, these real walls in this case. And then I have some invisible game walls, so they can't go up or down past what they can see. So now that I have the functionality working, I'm going to do a bit of cleanup in my project and my code. Now, first, my project hierarchy is getting pretty messy for now, so I'm going to create some empty game objects, at least just for the walls and for the enemies. Maybe just the walls. I'm probably going to delete the enemies later anyways. So I'm going to right-click in my hierarchy, and I'm going to create an empty game object. Now, in this case, this game object will actually just be all of our environment. So I'm going to name it environment. So if I add trees or rocks or whatever it may be, I'll just add it into this environment section unless I have a need to divide again. So this way, all of my environment will be kept underneath. I'm going to just make sure I reset this position, so that way it's in the exact center of our scene. And then I'm going to select both of my walls and drop them into the environment. So now they're both tied to my environment empty game object. Now I can collapse it, and I don't have to keep cluttering up my hierarchy, so I can keep track of the important things. In fact, no, I'll keep it. Around it for now. Now, I am going to clean up some of my script. So in my player controller script, I'm actually going to reorganize these variables really quick because it makes it a lot easier to read when you have all of your floats together, for example, versus all of your rigid bodies or all of your game objects. So that's good. I do want to, so I know what this line of code does. It just sets a rigid body to our player's rigid body. But I am doing some fancy stuff down here. So actually, I have a lot of code in here for player input, and then I have code in here for setting boundaries. So I'm actually going to split these up. So I'm going to add a new line. So I know that this will be the move player method, so we'll just add a comment here so we know what it does. So it moves the player based on arrow key input. Now this will be a void, and I'll call this move player. And then I can just take out these two lines, and if I cut it, paste it into move player, now I should just be able to call move player here. And then in my case, I am restricting the player to some invisible walls, so I'm going to make a method here, so I'll prevent the player from leaving the screen from the top, leaving the top or bottom of the screen. So we'll make this also be boundaries. So that's perfect. Last but not least, I'm going to save really quick. Now I'm going to create a backup of this version. So I'm going to right-click on my assets folder, export a package. I'm going to export everything. And now in my backups folder, I'm going to name this 0.2 because we made some progress, but it's not a full game yet. And then I'll click save. So what you're going to do